Algebra 2, this is Unit 10, Lesson 1, and today we're going to talk about end behavior of polynomials. So I used a calculator to look all these up, and you certainly can put them in your calculator also. We're just going to do a sketch of these functions. So you should already know what y equals x squared looks like. All right, so that's a parabola, and it looks just like that. I haven't moved it left, right. I haven't made it narrow or wider. I haven't moved it up, down. That's y equals x squared. And again, this is just a sketch, so mine's not perfect. Now, y equals negative x squared, the one right below it, I've done a reflection over the x-axis, so it's just going to be like the same thing, but upside down. Okay, those you can know without a calculator, I'm sure. Now, y equals x to the third looks like this, and you can put that in your calculator if you want to verify it. And y equals negative x to the third goes just in the opposite direction. Basically, again, I'm doing a reflection. So this part right here, okay, this part is going to be reflected, so everything is opposite and it's down here. And this part right here is going to reflect it, so everything's opposite and it's just like that. Right, just to show you, I wanted you to see that reflection. Y equals x to the fourth. Again, looks similar to y equals x squared, and y equals negative x to the fourth, then of course would just be the reflection over the x-axis. And y equals x to the fifth looks just like y equals x to the third. All right, so that the reflection, y equals negative x to the fifth, would be super similar. All right, so when I'm drawing these sketches, I'm really talking about the end behavior of the polynomials. The end behavior, also known as the long run of any polynomial, describes what's happening to the graph as your input is getting really large as it's approaching infinity, as your input gets really small as it's approaching negative infinity. So in order to talk about this end behavior, we do have to talk about the degree of a polynomial is your highest exponent. Okay, so the degree of a polynomial is your highest exponent. And the leading coefficient is the coefficient attached to the highest exponent. The coefficient attached to that highest exponent. And I really just want to look at the sign, because I want to know if it is reflected or not. All right, so look at sign. So the end behavior is always going to represent those power functions that I was talking about up above. So if you notice, all of the ones that were even, so look at these even ones here, highlight them in green, even, okay? They were all, the endpoints were facing in the same direction. And all the odd ones, endpoints were facing in different directions, meaning one was going up and one was going down. All right, so even if it's an even degree and a positive coefficient, those endpoints go up when you're going to the left as you're approaching negative infinity, and it goes up as you're approaching positive infinity. If it's even but negative, then both of those endpoints are going down. So it's going towards, as I'm going to the left, negative infinity, it's going down, and as I'm going to the right, positive infinity, it's going down. And when it's odd degree and positive, the right side goes up and the left side goes down. But if it's odd degree and negative, then the left side goes up and the right side goes down. So these are important, and we want to keep them in mind for the rest of this lesson that we're doing here. All right, so which of the following power functions is shown in the graph below? Explain your choice. Try and do it without a calculator. All right, so it's going down. That means I need a negative. So it's upside down. It's been reflected, so I need a negative. And both of those ends are going in the same direction. So if the ends are going in the same direction, it's positive. Ends both same direction. Then it is an even exponent. I said positive. So if it's upside down, it's a negative. But if the ends are going in the same direction, it's an even exponent. If the ends are going in different directions, then it's an odd exponent. So I'm looking for a negative, so it has to be choice 1 or choice 2. And I also need it to be even because the ends are going in the same direction, so therefore that's choice 2. Okay? 3, describe the end behavior of the polynomial function. Determine the maximum minimum number of roots. All right, so first of all, this is odd. So odd goes in different directions. And it's negative. So it's odd and negative. That means this is going to go like this, and this is going to go like that. Odd and negative, the left goes up and the right goes down. So as I'm approaching negative infinity, I'm going up. So that's positive infinity. And as x approaches positive infinity, so as x is going to the right, I'm going down. Now let's look at B. All I'm concerned about is that that highest exponent. All right, so it's odd and it's positive. Odd and positive looks like this. So as x is approaching the left, negative infinity, I'm going negative infinity. That's the end behavior. And as x approaches positive infinity to the right, I am going up, so that is positive infinity. Again, I'm just looking at that highest exponent, so it's even and negative. So that means your ends are going like this. So as x approaches negative infinity, it's going down. And as x approaches positive infinity on the right, it's also going down. And then for D, again, look at that highest degree. So it is even and positive. So that means it's going to go up on the left and up on the right. So as x approaches negative infinity on the left, I'm going up. And as x approaches positive infinity on the right, I am going up. All right. Describe the degree and the leading coefficient of the polynomial function. They're going in different directions, so it has to be an odd degree. And if it's going up on the left and down on the right, it is negative. I'm just taking those rules and I'm applying them in different ways. If both are going in the same direction, it is an even degree. And if they're both facing up, then it is a positive coefficient. All right, let's flip over the page. We got a few more on this page right here. So now we're going to try sketching it. So we're just taking those rules that we learned and we're doing it in different ways. So the leading coefficient is negative, and the highest degree is 4. So it's even and negative. Even and negative faces like this. Okay, so it can just, as long as both endpoints go down, it can be something like this. Okay, again, I know nothing else about it, so I can't be too exact. B, I have a leading coefficient that's positive, and the highest degree is 5. So it's odd and positive. Odd and positive goes like this. All right, so again, I have no idea what it looks like in the middle, but I know that to the left it's going down, and to the right it's going up. Sketch a degree of an even degree function that has no x-intercepts. So it's even means they both have to go up, but it has no x-intercepts, so it could be something like this. All right, that means those roots are imaginary. Can you sketch a graph of an odd degree polynomial that has no x-intercepts? You actually can't, because odd, remember, has to go like this, or it has to go like this, and that's impossible because it has no x-intercepts. All right, if it's going in two different directions, it would have to cross the x-intercept, so no. If odd goes in two different directions, would have to cross the x-axis. Okay, and we just have 6 and 7. Consider the function f of x equals 2x to the 4th plus x to the 3rd minus x squared plus 5x plus 3. Predict its end behavior and draw a sketch, then graph the function on a calculator to check your prediction. All right, so I'm looking just here at the highest degree right here. So it is even and it is positive. All right, so that means it has to go up and it has to go up. All right, so I'm just going to draw something up and up. And then you can put it in your calculator and just confirm that, but we'll go up in both directions. And this one, I have 2x to the 5th is my highest degree. So it's odd and positive. So that means that this end goes down and this end goes up. So, all right, I'm not sure what's happening in the middle there, but you can, again, confirm that with a calculator. All right, so we need to know those rules. And the rules, again, are the ones that I put a little star next to. So these are important to know. Those end, what it's looking at the end behavior, and we'll practice that tomorrow.